Okay. A very good afternoon to all of you, dear students. Welcome to the third session of Business Mathematics and Statistics, Paper 3 of your foundation. So first of all, thanks a lot for all the queries, and many of you are liking the classes. Thanks for your responses. Now I'll be sharing few points and then we will move on to some of the responses which I wanted to share with you regarding the queries raised by some of you and certain observations. First of all, please note that we have got just 2 hours to cover each chapter, and I'm trying to cover the theory. Then we are moving on to formula, and then of course we have so many practicals to do related to questions which have come in the study material of the institute and solutions of questions which have come in the exam as well as the model test paper. So it's a race against time, and 4,000 to 5,000 viewers are watching this program live, and basically you can see all these 4,000, 5,000 people and the students who are viewing the lectures later on. They come from different backgrounds. Some have commerce background, some have non-commerce background. So it's a very challenging thing for us to do. Plus, every day 300 to 400 queries are coming after the session. So it is not possible to answer individual queries, because if I do it, the full time will go. So what I am doing is I am filtering your questions, understanding the common areas and covering them in the session. Plus, I would also request you to note that every day once we complete the session, please, and the video is uploaded in YouTube, please go through it again, and the presentations are also shared. Every day the session presentation is shared, so you can go through it and you can practice those problems which are important in the sense that they have either come in the exam, I have indicated that, or they are from the additional question bank. Now, so please try to understand that there is a race against time, 2 hours, so much to do, and you are all intelligent. So please be patient and let's learn slowly, because this is just the start. There are so many chapters to do, and most important, we should be grateful to the institute for organizing this program. It's free of cost, and most importantly, it's a great support from the institute. And please have this feeling that yes, the CA community, we are all working together to make sure that you learn, and you learn in the right way. Second thing, of course, is yes, it is network based. It is a virtual class. It is a live virtual class. So there may be sometimes network problems. The network problems can take place in 3 stages. First is from my side, I am transmitting. There may be network problems. During the transmission, there may be problems. There may be interceptions. And finally, when you are receiving it in your smartphone, in your tablet, or in your laptop, there might be problems. There might be local network problems. So we have to go through it, because it's a virtual session. It cannot be as good as a live session, a physical session. Please remember that. And accordingly, we have to understand, we have to be very patient. Please practice the problems with me. And some of you have asked for shortcuts. You have said that, sir, can you teach shortcuts? Now, wherever there is a shortcut, I will always tell you. I have already told you, I will always tell you. But in every chapter, you will not be getting shortcuts. Please note that certain formula, there is no shortcut. You have to remember. Say, if I write, fx, ax squared plus bx plus c. This is a quadratic form. You have to remember, alpha and beta are the roots. So alpha plus beta equal to minus b by a, and alpha beta equal to c by a. This you have to remember. Similarly, for cubic equations, as I said, you have to note that the cubic equations has to be done only through trial and error method. So therefore, you have to be careful. Everywhere you may not be getting shortcuts. Formula have to be memorized. Calculation, speed, confidence and time management. These are the 4 basic requirements for cracking and being successful in CA Foundation, not just the mathematics paper, but also the accounts paper, also the economics paper, BCK and law. So please remember to have this mental attitude and the mental makeup to make sure that you learn, practice more under exam conditions. Otherwise, mathematics is that way may not be that familiar to you because many of you may not be coming from a maths background. This is not the same as accounts. Most of you have accounts background. You know something about economics, but many of us were not in touch with mathematics. So it will take some time. Have the patience. Slowly we will learn. I am covering maximum problems from the study material. Hello? हाँ बोलिए हाँ बोलिए स्टार्ट करूँ ओके स्टार्ट कर रहा हूँ ओके Right. So, you see, these are the points, and most important thing, as I said, is practicing the problems, and we have to practice on whiteboard. Why? Because first of all, maths is not a theory paper. So just by screen sharing, you will not be able to understand. You can only see the solution, but then the solution is already there in your study material. We have to work out the solution step by step. So screen sharing is not the solution, right? For papers like economics, law, even some part of accounts, it is theoretical. But here, entirely it is practical, right? So I hope you can understand that we have to go for step-by-step solution. Many of you have asked questions about how to frame equation. That the most important part of equations is to frame the equation from the question, right? So we have to explain step by step and not just show you the solution by screen sharing and by PPT. PPT mode is not going to work for, the mathematics, right? It is more practical. Please try to understand that. Well, I'll take the responses to the queries now. More than 300 queries have come for the last session, and I thank each and every one of you. I'm trying to pick up those queries which are common in nature and which are relevant for discussion. The first query has come that what is units place and what is tens place? So let us see any number. Say I'm writing the number 786. Right? So here 6 is the units place. And then on the left hand side, you have the tens place. And this is the hundredths place, right? So if I want to create a number, say it is y and z, the digit y is there in the tens place, right? And z is there in the units place. Automatically the number becomes, I told you the other day, 86 means what? 86 is equal to what? 10 into 8 plus 6. Similarly, this number yz, y is in the tens place and z is in the units place. So this number will be 10y plus z, right? So this is the units place, tens place and the hundredths place. Unit, tens and hundreds. Unit is the first digit on the right hand side, then you have the tens digit and then you have the hundred digit. Okay. The second question has come. What are the roots of a quadratic equation? Now we have discussed so much. X has two roots. If you take quadratic equation, ax square plus bx plus c equal to 0. X has two roots. Root. What is meant by roots? Some of you have asked. Roots are nothing but the solution. That means, say I take say I take a simple expression, right? Say I take x square minus 5x plus 6 equal to 0. X square minus 5x plus 6 equal to 0. That means the value of x, please note, the value of x for which this left hand side is equal to 0 will be the roots. So the root is what? The value of x. That means we want to find out the solution to this equation. For what value of x, this left hand side will become 0. So if you put x equal to 3 or x equal to 2, you will find that the left hand side, this equation will hold. So please note that this is meant by roots. And you know, we have done that in case of quadratic equation, we have seen that if alpha and beta are the roots, minus b by a and alpha beta equal to c by a. So this is meant by roots. These are the two roots. I will put it in this way, like for a key, in Hindi you call it tala. Tala kholna hai. For a lock, you need a key, right? So if there is only one key for a lock, that means it has one root. If there are duplicate keys, two keys for a lock, then we will call it like alpha, beta, two roots. Okay. So if you put the key inside, the lock will open. Similarly, if you put the value of x here, the equation will be solved, right? I hope you understand this. Okay, the third query has come from Marilyn Maria Jose from Pondi, also from Shubha from Karnataka. I'm sure you are watching this live session and you have asked the question regarding cubic equation. You have requested me to do one more cubic equation. We did it last day. Today our main focus is matrix and Cramer's rule. But I promise I will do one cubic equation so that you understand once again the trial and error method which we use for solving cubic equation. Then the next query has come from Samanvita B from Karnataka and she has asked the question, how to get the model test paper. Many of you have asked the similar question, how to get the model test paper. Now I request you to download the model test paper from ICAI.org. Just go to the link foundation course, then you will get the study material. So just go to foundation course ICAI. So the link is like this, ICAI.org. You go to foundation, then you will get the study materials, the study mat. You will also get, please remember the study mat is updated. Very frequently the Board of Studies updates the study material. So please go through it, not just for mathematics, but for all papers, all your 4 subjects. Study material, there you will find also the amendment. If there is any amendment, if there is any change, if there is any upgradation of the study material, if additional examples are discussed, you will get that, and here you will get MTP. So, model test paper, right? So, please go through it. I'm sure right now the model test paper of May 2020 exams have been uploaded. Last class, if you remember, when I took up equations part 2, I had solved questions from the model test paper 2020. Please download the model test paper. You have the problems, the question paper, as well as the solution. So, for all subjects, not just for mathematics, all for accounts, for law, for economics, please download and study. The next question has come from Yogesh. Yogesh from Jaipur and Annapurna from Chennai. They have asked the question, where to get the additional question bank? Please note that at the end of your study materials, at the end of every chapter exercise, you will be getting the question bank, additional question bank, several pages of questions. Some of them have come in the exam. Some of them are very likely to come in the exam. All very, very important questions. Please go through that. My request to you, please go through those questions, solve it. Again, not just for accounts or law, but also for mathematics, economics, all papers. Okay. Next question has come, how to find the presentations of the LVC session, live virtual classes session. Please note the link I'm sharing. All the presentations are uploaded for each and every session. The link is http. You will be getting ICAI ecpl.live/BOS/VCC. So this is the link for the LVC PPT. So please, ICAI.ecpl.live/BOS/VCC. Okay. The next question has come Agarwal from Faridabad. Now, she has asked an important question, how to view the previous classes lecture. You know that each and every lecture, each and every session is uploaded in YouTube, and the channel is ICAI CA Tube. So this is the channel ICAI CA Tube. So please view these lectures. Once they are uploaded, you know that the lectures are now streaming online. It is a live streaming, and once the session is over, these will be uploaded in ICAI CA Tube channel. Please go through it. Sumanita Panchangam from Chittor has stated, material or not, will the exam questions come from the study material? Well, no clear-cut answer to this. Questions may, of course, will be similar to the questions you are studying in the study material. It may not be exact copy, but then if you practice from the study material, if you practice from the MTP model test paper and the additional question bank, I'm sure you will be more than adequate preparation you will be able to achieve, not just for mathematics, but also for the other papers. So, study material questions, the ones which are solved, and the questions which are there in the exercises at the end, please practice. My earnest request to all of you. Verma from Agra has stated that it's a very interesting question. Many others have also written questions like this, that will the duration of 2 hours be enough to complete the examination? Okay? Is the time of 2 hours enough to complete the exam? Well, my response to this is, everything depends on the type of questions, the difficulty of the questions, your preparation level, and speed, accuracy, and your mental condition. But I will share tips. I am sharing some tips now. logical reasoning. Logical reasoning of 20 marks is one of the easiest part in the mathematics syllabus. So try to complete, once you get the question paper, logical reasoning you can always complete because you will get 20 marks easy, comparatively easier, and if you can complete the questions fast, you get the confidence to take care of the other questions. So first, please try to complete logical reasoning, step number 1. Step number 2, try to handle the problems, try to solve the problems which are coming on equations, ratio, proportion, logarithms, indices, and equations. You will see questions will come on 3 areas: linear equation, quadratic equation, and third is matrix, which we shall be doing today. Okay. After you complete this, arithmetic progression and geometric progression. So AP and GP you should take up. So I'm just discussing a sequence of how you can solve the problems one by one. Always try to handle those problems which are easier and ones which you know. It is always better to handle and complete the problems where you are confident. Please don't start with a problem which is difficult because you will lose time. And CA Foundation is an exam where time management is very important, right? So please make sure you handle and complete the easier problems first. So after AP and GP, you can move to time value of money, the problems which will come on time value of money. Friends, almost 20% to 25% of the marks allotted for business mathematics will come from time value of money. So please remember to handle those problems because this is a very important chapter, time value of money, very important like matrix, like equations. So please make sure that you handle and complete those problems so that you get the necessary confidence to complete the exam. Then permutation combination, sets, relations and functions, and finally I will say differential calculus and integral calculus. So once you get the question paper, even when you practice the mock test paper, you have to complete in 2 hours time. Whatever be the negative marks, yes, negative marks are there. So it's a game of speed and accuracy and correct decision making. So the flow should be like this. I am a student. Let me complete the easiest part. Let me complete logical reasoning questions so that I get good amount of marks and I increase my confidence. From there, I move on to equations, indices, log. And once I complete that, I move on to AP-GP. Then time value of money, because time value of money has number of questions. If you do it correctly, if you know the formula, if your concept is clear, yes, you will score. After time value of money, permutation combination, which requires some thinking. After you are through with permutation combination, then you can handle sets, relations, functions, finally the differential calculus part and the integral calculus part. So this could be a way, this is just my way of explaining how you can handle the questions, in what sequence should you be handling the questions in the exam. A very interesting question and response, a query has come from Mr. Bharat from Kerala. Now he is asking, how do we know if the equation has one variable or two variables in forming the from the question? Additional questions of the study material. So Mr. Bharat, you have 2 questions. The first question is how to know how many equations are there. Now I would put it in this way, if there is one unknown, say they give you a problem where they say that a simple equation. Okay, so say 5x is equal to something like this. 5x is 80, for example. So you know this is only one variable. X is 16, right? But if you get a question like father and son's age, okay, 5 years ago, father was older to his son by 30 years. 5 years from now, he will be like 3 times. If this type of questions come, that means it is a question involving both the father's age and the son's age. So 2 equations has to be formed, x and y, because there are 2 unknowns, right? Similarly, for a quadratic equation, you know already, I have explained in details in the last 2 sessions that for a quadratic equation, x square plus say 6x plus 9, right? Just to give an example. So x square means there will be two roots, okay? And we have discussed that the roots can be equal roots, the roots can be real and unequal, and the roots can be imaginary also, right? So this is how you know how many roots will be there. So in a quadratic equation, you will have two roots. Finally, if they give you a simultaneous linear equation, x, y and z, three unknowns, it means there will be three equations. If there are three unknowns, three equations, you have to use substitution, you have to use elimination method which we have discussed, and you have to get the values of x, y and z. So thanks to Mr. Bharat from Kerala for asking this question, that's why I discussed it. Now I move on to the question which has come from Miss Kirtana from Chennai. Miss Kirtana from Chennai, she has stated that, sir, it is easy to solve the problems in the ICAI study material, but it is more difficult to frame the equation from the given question. Thanks to Kirta for her observation. Now, this is what I was telling you, and this is what I was teaching you also, how to frame the equation from the given question. And that's why I broke down each and every question into parts. I took almost 5-6 minutes to explain each problem because you have to learn. I am not coming here to solve quickly and go to the next problem. You have to learn. That's why I was teaching step by step. Today also, because of the queries, so many queries are coming, it's great to see your interest in mathematics. So, I will take up few questions and I'll show you how to frame the equation also. Okay, so last day we have done the simple equations, linear equations, simultaneous linear equations, quadratic equation, and I also discussed about cubic equation. Today our focus is, I will first take up just 5 examples. One example on simultaneous equation, one example on quadratic equation, one example on cubic equation, and one on a problem, numerical problem, all from the study material, from the exercises, so that you can further get the idea of how to solve it step by step. Then we shall move on to matrix algebra, where we will learn about row matrix, column matrix, addition of two matrices, subtraction of matrices, scalar multiplication of matrices, and then we will learn what is determinant. There is a term called determinant, and finally we will wrap up with a very important rule which is called Cramer's rule. Cramer's rule, right? So this rule, Cramer's rule, is used for solving simultaneous linear equations in 2 and 3 unknowns. So x and y, two equations are given. You can solve it. Shortcut method. It's a shortcut method, right? It is a shortcut because it takes less time, right? But you have to remember what is determinants. We will see that, right? So this is what we have today. I will first take, plus I will solve questions from the CA exam and the model test paper as well. Okay. The first question, right? Let me take the first question. So these are revision questions, and please have pen and paper. The idea is, as I said, this is mathematics. It is totally different from theory paper. It is not accounts, because most of you are familiar with accounts, but for many of you, maths is new in the sense you are not in touch with maths. Many of you, if I request to you, please have pen and paper, step by step. Okay, the first question, I am taking example number 1. X and y, you have to solve for x and y. X plus 2y equal to 13. And 3x plus y equal to 14. Okay? So please note the problem, x plus 2y equal to 13 and 3x plus y equal to 14. Okay? So let us do it step by step. Okay, first. So you have 2y here. Okay, step number 1, you have 2y. But here we have only y, right? Here we are having only y. So what to do? Let us eliminate y and y. But I have only y here. So I need to get 2y so that I can deduct the 2y from here. How can I do it? How can I get 2y here? If I multiply the full equation by 2. So this entire equation, I am multiplying 2 by 2. Right? So what will I get? 2 into 3x, 6x, plus 2 into y, 2y, equal to 2 into 14, 28. I hope you can see. And so we had x plus 2y equal to 13. 3x plus y equal to 14. We have multiplied equation 2 by 2 so that we get 2y. Now, if you just subtract, so this is the new equation. Okay? This is the new equation. This equation I am bringing here. So, x plus 2y equal to 13. Okay? Right? X plus 2y equal to 13. So what we do now? We subtract. So this is equation A equal to 28 minus 13, which is 15. So x is equal to 15 by 5, that is 3. Okay, please see the solution. So this is how many of you are asking, why do we multiply an equation? We multiply an equation so that we can knock out either x or y. Okay, so this is how we reach x is equal to 3. If x is equal to 3, then I am equal to 3 here in the first equation. So I have 3 plus 2y equal to 13, which means 3 plus 2y equal to 13. It means 2y is equal to 13 minus 3, that is 10. If 2y is equal to 10, then y is equal to 5. Okay? So, what is the solution? The solution is x is equal to 3, y is equal to 5. Okay? I hope this is clear. Step by step, right? And using your intelligence. So this is the first example. We will do 5 examples and then we move on to matrix and determinants and Cramer's rule. Right? So I'm rubbing it out. I hope you have understood this. Simple. Very simple. Okay. Now we go to the second question. This is the easiest one. 2 variables. Now I request you to go to page number 2.7. So page number 2.7 of your study material. Page number 2.7, exercise 1. Exercise 1, page number 2.7. Okay. So the problem, right? The problem is page 2.7 and exercise number 1. Okay. So we have x, y and z. So 3 unknowns. So first I took the example of a linear equation with 2 variables, x and y. Now I take up an equation with 3 variables. So 2x minus y plus z equal to 3. Then we have x plus 3y minus 2z is equal to 11. And we have 3x minus 2y plus 4z equal to 1. Right? We have to find the value of x, y and z. So 3 equations in front of you. 2x minus y plus z equal to 3. X plus 3y minus 2z equal to 11. And 3x minus 2y plus 4z is equal to 1. Okay, so how to proceed, right? In the exam, you have to be very fast, but let's learn slowly and then we practice and pick up the speed. Okay, so first what to do? So let us first take this and this. Okay. You have 2x here, but you have only x here. Y, 3y, z, 2z. So if I want to eliminate x, so in this case, in this type of questions, first equation 1 and 2, and then you have equation 3. First you take up 1 and 2. So 1 and 2. Okay, you will get a relation. You will get y and z because we will knock out x. Again you take 1 and 3. Equation 1 and 3. You will get a further equation. From here you can solve. So let us see how to use this. So always remember the rule is first take equation 1 and 2, eliminate one of the variable x, for example. Again take equation 1 and 3. Again you eliminate the variable. So ultimately you will get two equations, this and this. And you will get two variables. So from three equations, we are reducing it to two equations. Right? Two variables, two equations. From complicated to simple. Okay, so let's do it. So let's see what will be the approach. So 3x. So what we do, equation 1 is given. We multiply equation 2 by 2. So equation 2 into 2. Okay. So we get 2 into x, 2x, plus 2 into 3y, 6y, plus 2 into minus 2z, that is minus 4z, is equal to 2 into 11, so 22. Okay. This is the new equation. And here you have 2x minus y plus z equal to 3. This one. So, if you subtract minus, okay, so you get 2x minus 2x, gone. 6y minus y. Please note you have a minus sign here, minus sign. So 6y minus y means 6y plus y. So you get 7y. Here you have minus 4z, but here you have plus z. But we are subtracting. So it will become minus 4 minus z. Minus 4z minus z. That means minus 5z. And on the right hand side, 22 minus 3. Which is how much? Which is 19. So this is the first equation. I am writing it here. 7y minus 5z equal to 19. Okay. So this is the first part where we have dealt with equation 1 and equation 2. Okay. I am rubbing this part. Okay. Now we will take up equation 1 and equation 3. So this time we are taking up equation 1 and equation 3. So this one and this one. Okay. So let's see what to do. Please note that you have 2x here, you have 3x. Okay? Please note that the equation we have now got only has y and z. No x, only y and z. So here, when you eliminate 1 and 3 from 1 and 3, right? You have to eliminate x so that you can get y and z again. Okay? So you have 2x here, but you have 3x. So what to do? Let us multiply 2 and 3. You know the LCM is 6. So let us multiply this equation, equation 1 by 3. So equation 1 into 3. So what do we get? Let us see. So we are getting 6x 3 into 2x. 6x minus 3 into y minus 3y plus 3z is equal to 3 into 3, 9. Okay? And equation 3, it is already given 3x minus 2y. So you have 3x here. if you multiply it by 2, then you will get 6x. And 6x and this 6x will cancel. Okay? So, I am multiplying equation 3 by 2. So, equation 3 multiplied by 2. So, you get 6x, 2 into 3x, minus 2 into 2, 4y, plus 8z. Okay. So 2 into 3, 6x, 2 into 2, 4, 2 into 4, 8z is equal to 2 into 1, 2. Please see if you have got, I'm sure you are doing the problem with me. Please see if you have got these two equations. So now again we subtract. 6x minus 6x gone. 6x minus 6x is cancelled out. This is cancelled. Minus 3y. Here we have minus 4y. So this is minus 3 minus of minus 4. Minus of minus and minus becomes plus. So this will be minus 3 plus 4. So here minus 3y minus of minus 4y. So it becomes minus 3y plus 4y, that is only y. Here you have 3z. You have minus 8. So it will become y minus 8z equal to 9 minus 2, that is 7. Y minus 8z equal to 7, I put it up here. Y minus 8z equal to 7. Okay, now I am wrapping up this part. I hope you have reached. Up till now you have understood. Okay. Now we are dealing with, please see that we are dealing with two unknowns. So you have 7y minus 5z equal to 19 and you have y minus 8z equal to 7. Okay. Just check. We'll just do once again. If you are not following, we'll just do this part once again. So what we did first was 2x minus y. First equation I think you have understood. Let us take the second equation once again. X plus 3y, x, 2x minus y plus z equal to 3. And we have got, in the third equation was 3x minus 2y plus 4z equal to 1. So from here what we did, we multiplied this equation by 3. So we got 6x minus 3y plus 3z equal to 9. And equation 2 we multiplied by 2. Equation 3, sorry, multiplied by 2. So we got 6x minus 4y plus 8z equal to 2. So from here we are getting 6x cancels out. Minus 3y minus 4y becomes minus 3y plus 4y. So this becomes y plus 3z minus 8z. You get minus 5z. So y minus 5z equals 9 minus 2, 7. So we are getting the y minus z equal to 19 and minus 5z equal to 7. So let us solve these two equations to get the final answer. Okay. So here you can see that you have 7y minus 5z equal to 19, y minus 5z equal to 7. So from three equations we have come to two equations. So straight away we subtract. Minus 7y minus y is 6y minus 5z minus of minus 5z. So it is minus 5z minus of minus 5z, which means this and this becomes plus. So minus 5z plus 5z. So it becomes 0. It is cancelled out. So you have 6y equal to 19 minus 7, which is 12. So y comes to 12 by 6, which is 2. So we have got y. If you get y, so let us take the equation here. Y minus 5z equal to 7. You know y is equal to 2. So I will write here 2 minus 5z equal to 7, which means 5z equal to minus 5. Just transposing. Okay. So z equal to minus 1. So we have got y equal to 2 and we get z equal to minus 1. So we have got y and z. Now go back to the first equation. The first equation was 2x minus y plus z equal to 3. You have already got y. So y is 2. So minus 2. And z is minus 1. So minus 1. This is equal to 3. So 2x minus 2 minus 1 is equal to 3. That means 2x minus 3 is equal to 3. So x is how much? 2x minus 3 is 3. So 2x is 6. X is equal to 3. So from this equation we get x equal to 3. Okay. So and I broke it down into steps. So this is the toughest you get and I hope you have understood it. The solution is x is equal to 3. Y we have already found first. Y is 2 and z equal to minus 1. Okay. This is solution to example which is given in page number 2.7 of your study material exam exercise 1. So I did a question from the exercise. Okay. Now we go to example exercise B unit 1. Okay. So page 2.5. So please go to page 2.5. Page 2.5 of the study material, unit 1, exercise B, and I am doing question number 1. Please see the question. The sum of two numbers is 52. Sum of two numbers equal to 52. The difference, their difference equal to 2. Find the numbers. What are the numbers? Okay, sum of two numbers is 52 and the difference is 2. So what are the numbers? Now, Kirtana from Chennai had asked this question, that how to create the equation from the question. Okay, so I'm sure Kirtana is watching this episode and others, many other friends who were part of the session last day had asked a similar question. That's why I'm taking it up, because our objective is to clear your doubts. Our objective is to make sure that you get clarification to your queries to the extent possible, because time, you know, only 2 hours. So much to do, so little time. Okay, but let's see this. How to do it. Okay, so I hope you have seen the question now, right? So this is a question where you have two variables. The sum of two numbers is 52 and their difference is 2. So what are the numbers? Very simple question. Let the numbers be x and y, because there are two unknowns. So the numbers are x and y. The sum of the two numbers, 52. So x plus y equal to 52. X plus y equal to 52. First condition, the first relation, x plus y equal to 52. Second, their difference is 2. So x minus y is equal to 2. Right? So this is first equation, this is second equation. From here, if you just add up, if you add the two equations, plus x plus x, 2x, plus y, plus of minus y, plus y, plus of minus y, means it is 0. They cancel out. So it cancels out. This is equal to 52 plus 2 is 54. So from here, x is equal to 54 by 2, that is 27. Okay? So one of the number is 27. Okay? If one of the number is 27, right? You know that the sum of the two numbers is 52. So if one of the number is 27, if x is 27, then y is equal to how much? 52 minus x, that is 52 minus 27, that comes to 25. Okay? So 52 minus 27, that is 25. So the numbers are 27 and 25. Right? I hope you have followed it, and this is from Unit 1, question number 1, exercise 2.5. Okay. We now proceed to, I'm rubbing it out, I hope you have followed it and understood it. So these I am doing only for the queries which have come to make sure that you follow and understand, and as we go to the next one. This is page number 2.21. Page 2.21. Okay, Unit 1. Unit 1, exercise F. Exercise F. Exercise F. Question number is 4. Okay. Please find the question. Please open the question. So the question is, if alpha and beta relation 2x minus 4x minus 3 equal to 0. This is the equation. 2x square minus 4x minus 3 is equal to 0. These are the roots. These are the roots of the equation 0. Then alpha square plus beta square equal to how much? So we have to find. Okay. Friends, last 2 days I have been requesting you to revise the basic algebraic equations, because this will be useful in solving these type of questions. And this is a square plus b square, and you know that a square plus b square is equal to a plus b whole square minus 2ab. So you can understand that 2x square minus 4x minus 3 equal to 0. So it has two roots, alpha and beta, right? You also know that alpha and beta has a relation. The two roots of a quadratic equation has certain relation. What is that? Alpha plus beta we know is minus b by a. Here, b is equal to how much? Minus 4. C is equal to how much? Minus 3. And a is equal to how much? 2. So 2x square minus 4x minus 3, this is of the form ax square plus bx plus c, and a is 2, b is minus 4, and c is minus 3. So alpha plus beta equal to minus b by a, which means here b is 4. So minus of minus 4 by 2. Which is 2 and beta. Alpha beta equal to c by a. Alpha beta is equal to c by a. Okay, this we have done. Now c is how much? In this equation c is minus 3. So c by a means minus 3 by 2, because a is 2. C is minus 3. A is 2. So c by a means minus 3 by 2. Okay. So we have got two relations, that is alpha plus beta equal to 2 and alpha beta equal to minus 3 by 2. You have to find alpha square plus beta square. Understand that alpha square plus beta square is equal to alpha plus beta whole square minus 2 into alpha beta. This is the basic algebraic equation which we learnt in school. A plus b whole square is equal to a square plus b square plus 2ab. So a square plus b square is how much? A plus b whole square minus 2ab. That is what we have done. Now please see here, alpha plus beta you know, this is 2. So 2 square. So we have 2 square minus 2 alpha beta. 2 into alpha beta, that is 2 into minus 3 by 2. 2 and 2 cancels. So you have 2 square is 4 minus of minus 3. That is equal to 7. So the answer is, if alpha and beta are the roots of the equation 2x square minus 4x minus 3, then alpha square plus beta square is coming to 7. Answer is 7. I hope you have seen how to use algebraic equations and formula in order to solve the problem. Okay.
Excuse me.
Now
Sir.
we will take, since some of you were asking about cubic equation, the last one I'll take is the cubic equation, then we will move into matrix.
Sir.
Okay. Hello?
Would you able to hear,
Yes.
sir? Yes, sir.
Yes, I am able to hear.
We can go ahead with the matrices, sir. Actually, time is very short, actually.
Right. Okay. Fine. Okay, let's go to matrices. Fine. So, what is the matrix? You know, matrix is a simple way to see. Matrix is a simple way. It is like an array. If you open your study material, you will find that matrix is of the form different numbers, right? So you have maybe 5, 6, 7, 1, 0, 4, 6, 9, 3. This is a matrix. Another matrix can be like this: 5, 4, 6, 9. Okay, so you have two numbers in the row, two numbers, 5 and 4. And again in the column you have 6 and 9. Sorry, 5 and 6, this column. So row number 1 is 5 and 4. Row number 2 is 6 and 9. Okay? This is a separate part of equations. First we understand what is matrix. Then we shall see how to add matrices, how to multiply matrices. Then we will see determinants and then Cramer's rule. That's how we will end. Okay. So this is a 2 by 2 matrix. 2 by 2. Now when you enter into a bus, right? So you are going in a Volvo bus from Chennai to Bangalore, right? So you enter the bus, you find 2 seats on the left hand side, 2 seats on the right hand side. Okay? Right? So you call it 2 by 2 bus. Because there are 2 seats on the left, 2 seats on the right hand side. Okay? The seat. Okay? Now, so 2 by 2 is a bus. Or you go by express. You enter an aircraft. Once you enter into an aircraft or Air India, if you enter into the economy, 3 seats on the left hand side, so like this, 3 seats, 3 seats. So we call it 3 by 3. Okay. So matrix is nothing but what? It is a numbers. There's numbers given into row. This is row and this is column. So if you see in this particular case, I have written few numbers here. 5, 6, 7. This is row number 1. 104, row number 2. 693 is row number 3. Column number, if you see the column number, 516 is a column number. First column. Second column, 609. And the third column, 743. Okay. So you have row 1, 2, 3 and column 1, 2, 3. In this case, in the second case, in this case, you have row number 1 is 5 and 4. Row number 2 is 6 and 9. Column number 1, so C1, column 1 is 5 and 6. Column 2 is 4 and 9. 4 and 9. Okay, so please remember, matrix means numbers which are arranged in the form, we normally show matrix like this, or we show it like this. It can be a square matrix, right? A square matrix means, like for example, 3 by 3, or 2 by 2, or 4 by 4. Let us draw a 4 by 4 matrix. So 1, 3, 2, 5. Random numbers, 6, 8, minus 1, 7, 8, 10, minus 4, 6, 2, 4, 6, 8. So this is a 4 by 4 matrix. 4 columns, column number 1, 2, 3 and 4, and 4 rows. Row number 1 is 1, 3, 2, 5. Row number 2 is 6, 8, minus 1 and 7. Row number 3 is 8, 10, minus 4 and 6. And row number 4 is 2, 4, 6, 8. Okay. So this is a square matrix. Square. Because in a square you know that this side is equal to this side. Okay. In a square, the length and breadth are same. Okay. So in this matrix, it is a 4 by 4 matrix, a square matrix. Right? Now, there can be a rectangular matrix also. So it can be like this. 1, 7, 5, minus 4. 6, 8, 2, and say, let's call it 9. So here what happens? Here what happens? Is it a square matrix? Square? No, not a square matrix. It's a rectangular. It's a rectangular matrix. Because it is 4 rows, 4 columns and 2 rows. So it is 2 by 4. Okay, 2 rows and 4 columns. Row number 1, 1, 7, 5 and minus 4. Row number 2, 6, 8, 2 and 9. Column number 1, 1 and 6. Column number 2, 7 and 8. Column number 3, 5 and 2. Column number 4, minus 4 and 9. Okay. So, I have stated, I have discussed, we have started with matrix. And you can understand that matrix is an arrangement of numbers. Right? With row and column. Right? It is an array of numbers. You see in the study material, if you see, we always follow the study material. In the study material, you see it is written, it is an array of numbers. Array. What do you mean by array of numbers? Array means the arrangement of numbers. Arrangement of numbers which has a row and which has a column. If the number of rows and if the number of columns are same, like 4 rows, 4 columns, then it's a square matrix. If the number of rows and columns are not equal, then it is a rectangular matrix. Okay, so in general, when we draw a matrix, okay, I'm coming to this now. So very easy, this is, I can assure you this is easier than equations. Sometimes some people, when I see your responses, I think, oh God, how some of you are so worried. Don't be worried. Just chill out and you will understand slowly. I'm sure first day when we discussed about equations, you had so many questions, but in 2 days, 4 or 5 hours of interaction, I am sure at least your confidence level has increased and you have understood the process of solving equations, linear, quadratic, cubic, etc. Right? If we get some time later on, or if we can have any other session, I will take up some other examples from cubic and quadratic. But let us now focus on matrix, because that is our primary, agenda today. Matrix and Cramer's rule. Right? That is what I was saying, that we have so much to do, but you have to also understand that so many queries are coming. So we also need to respond to you. At the same time, we have to carry on with the syllabus. It's a very, challenging task. So please also make sure that you learn. Don't just rly on the live virtual classes. Practice, study the chapter. You already have got the schedule. So please study the chapter before we start that session. So in general, okay, now I am writing in mathematical terms. First one was easy. Now I will write in mathematical terms. So normally we write A11, A12, A13, A14. I am writing a 4 by 4 matrix. If it is more, then it can go up to A1n. Okay. So this is the row. The next will be what? The row number is 2, but the column number is 1. So the number is A21. So this will be A22, A23, A24 up to A2n. Right? Very simple. Mathematics is simple. You understand, you use your common sense, your intelligence. Yes, matrix looks like the movie. Many of you might have seen the movie Matrix. Right? I'm sure. You are young fellows, you must have seen the movie. But this is also going to be interesting. Don't worry. So this is like this. So the third row will be A31, A32, A33, A34 and up till A3n. Okay? And the fourth row, we are taking a 4 by 4 matrix. So we will just make sure that we have the fourth row as well. So this is A41. Fourth row means A41, A42, A43 and A44 up till A4n. Okay. So in this way we can go down. I am just considering a 4 by 4 matrix. So you have, this is the row, and this is the column. Okay. So the horizontal part is the row and the vertical portion is the column. So we have seen that matrix, array of numbers, arrangement of numbers, number one. Number two is, it has numbers arranged into rows and columns. If number of rows and number of columns are equal, we call it a square matrix. If the number of rows and columns are not equal, we would call it a rectangular matrix. Okay? And this is how we draw a matrix. So this side, A11, A12, A13. So please note that in general we can write Aij. Okay. Now as you move along the row, right, what will happen? A11, A12, A13, A14. Please note this 1 is same, but the second number is increasing. 1, 2, 3, 4, 5, 6. So the first number is I and the second number is J. So J will increase. J1, J2, J3 as we move into this side. So the J will increase along the row. The J will change. J changes as we move it along the rows. And as we move along the column, what will happen? A11, but the second one is A21. This is column 1. A31, A41. That means as we move down the column, the first number changes. A11. Next number is A21, A31. So the second number remains same. The second number remains constant, but the first number is changing. The first number is changing. So this is an example where in case of the column, I will change. I changes. So when we talk of Aij, right, when we talk of Aij to denote any number in the matrix, we use the term Aij, and as we move, we have I will change as we move along the column, and as we move along the row, we will find that J will change, right? So till now, let us summarize what we have learned. Matrix is an arrangement of numbers. Okay? Matrix is an arrangement of numbers. It is an array of numbers. There are rows and there are columns. Right? If the number of rows and the number of columns are same, it's a square matrix. If it is not same, it is a rectangular matrix. And matrix can be a 2 by 2 matrix. Right? So if I 2 by 2 matrix, say 1, 2, 4, 5. It's a 2 by 2 matrix. Okay. If I write 5, 6, 8. So this is what? A 3 by 2. This is a 3 by 2. This is 2 by 2. So matrix can be 2 by 2, 3 by 3, 3 by 2, 4 by 4, any combination. Of course, if the number of rows and the number of columns are same, it is a square matrix. Please remember. Now we go into, let's go into, okay. Now row matrix and column matrix. So page number, we are doing now page number 2.3637. So, okay, I'm rubbing this part. So the first point in matrix we have learned is that it is an array of numbers, right? It's an arrangement of numbers, and we have also learned that it has rows and columns. And we also saw that the general term which is used is Aij. This is the general term in a matrix. Okay, I is the first number, J is the second number, and as we move along this direction, that is, as we move along the horizontal direction, right? As we move along the horizontal direction, this side, we find that J changes. So J moves in the linear. So J will change. J changes. Okay. And as we move in the vertical, up to down, then we find that vertical, we find that I is changing. So here, I will change. Okay. Now we go into, this is page 2.36, 2.37 onwards. So now we go into row matrix and column matrix. Okay. So please remember this one, Aij. So matrix is an array of numbers. It has rows and columns. The general term, it's an array of numbers, rows and columns. You can have 2 into 2, 3 into 2, 3 into 3, 4 into 3, 4 into 4, 4 into 2, any combination of matrix, any combination. So the row and column can be of any combination. Okay? Right. And we also saw the general term is Aij, I and J, where I will change as we move down, as we go vertical. So V, and J will change as we go into linear, straight line, linear and vertical. Okay. So now what is row matrix and column matrix? So this much I am writing here. So row matrix and column matrix. So you know that it is composed of rows and columns. So a row matrix, if you have only one row, so say this is 5, 4, 1. Okay. That means the type is A1, A2, A3. Only a row. It is a row matrix. Okay. So if you have only a row, it is row matrix. Right? And if you have, there are two types of matrices, row matrix and column matrix. So this is a row matrix, only one row. What is a column? Column matrix. When you have one column, okay, so sometimes it is called a column matrix or a column vector also. So like this, say 1, 6, 8. This is only one column. So the general term is A1, A2, A3. When vertical, it's vertical. This is a column matrix. Row matrix. Horizontal, and take this matrix. Okay. Okay. So sometimes in my school I was not good in studies, so I used to get a report card like this, you know. So 0 in maths, 0 in English, 0 in Hindi, 0 in geography, 0 in history, 0 in physical education. So 0, all zeros. So this type of matrix is known as null matrix. Null matrix. Okay. Or it is also called zero matrix. Okay. So we have discussed till now, matrix is an arrangement of numbers divided into rows and columns, right? It can be a square matrix, it can be a rectangular matrix, right? Then we discussed 2 by 2, 3 by 3, 4 by 4, and we also discussed about the terms Aij, right? And the fact that as you go linear, as you go from the left hand side to the right hand side, which one will change? J will change, and as you go down from the top to the down, I will change. I, that is the first digit. Okay, right. Now we move on to, so square matrix we have done, now we go to scalar matrix. Okay, scalar matrix. We are proceeding as per the study material, strictly as per the ICAI syllabus and the study material. So now we go to scalar. So what is scalar matrix? Now let me draw a matrix. K 0 0, 0 K 0, 0 0 K. Okay. Now many of you remember in school when you were a child, when you grew up, this is something we always used to play. Remember? So I will do this, he will do this, right? You remember that the first person to get diagonals will win, right? So this is a very fun game we used to play, and we still play. So if you do this, I do here, you do this, I do here, you do this, you win. Similarly, diagonally also, if you have three same, so you have started with this, I write here, you start here, I write here, you start here, you win. Diagonal. Okay, so this is diagonal. Okay, please see, a scalar matrix is a matrix whose diagonal elements are all equal. Diagonal. Your diagonal. Here the diagonal. The diagonal numbers are all equal. It is equal to k. So this is called scalar matrix. Okay, please remember. Okay. Now we go to unit matrix. You can refer to 2.37, page number 2.37, page number 2.37 of your study material. We are discussing scalar matrix, and now we go to unit matrix. So what is unit matrix? In scalar matrix we found that the leading diagonal, if all the numbers are same, then we call it a scalar matrix. What is unit matrix? So now we go to unit matrix. So you know that unit means what? 1. Unity. We must have unity. That means we must be one. We must, be united. We have to fight like one army, one nation, one tax, one market. Okay. One exam, CA, only one exam, conducted only by ICAI. Okay. So unit means one. Unity means to be together, to be one. So unit matrix means a matrix where K equal to 1. So a matrix where K is equal to 1, that means a unit matrix will be like this. So I'm drawing a 4 by 4 matrix. 1, 0, 0, 0. 0, 1, 0, 0. 0, 0, 1, 0. 0, 0, 0, 1. Okay. So here, if you see diagonal, I hope you are logged in and listening. If you see the diagonal, 1, 1, 1, 1. Here, scalar matrix K, K, K. I have taken a 3 by 3. Here I have taken a 4 by 4. A 4 by 4 matrix. 4 by 4 matrix. Okay. So you can see this is a unit matrix because all the elements on the leading diagonal of the matrix is equal to unit matrix. Right? So, lot of new ideas we are getting. A matrix is array of numbers divided into rows and columns, columns and rows. It can be a square matrix. It can. Then we discussed 2 by 2, 3 by 3, right? 4 by 4, and then we saw that the matrix, general term of a matrix is Aij. And as we move along the linear direction, horizontal direction, J will change. As we move downwards or upwards, as we move vertically, I will change. Right? Then we saw what is a scalar matrix, and now we are seeing what is 2.38. Page number 2.38 of your study material. 2.38. Okay. Now we are moving to something called upper triangle matrix. So I am drawing a particular matrix. Okay, this is how we draw a matrix. So 1, 6, 5, 0, 3, 4 and 0, 0, 2. Please see the matrix carefully. 1, 6, 5. Please draw with me. I request all of the students who are watching this to please draw with me. This is a very interesting chapter, just like equations. And the best way to learn this is to learn together and make sure that, we learn together and we practice together. We have to practice together. So the matrix is 1, 6, 5, 0, 3, 4 and 0, 0, 2. Okay. 1, 6, 5, 0, 3, 4 and 0, 0, 2. So if you see, the diagonal is here. This is the diagonal. But please see that all the digits below the diagonal, all digits below the diagonal, okay, all the digits are 0. Let's see, 0, which means this is called an upper triangle matrix. Okay, this is called an upper triangle matrix where all below the so if this is an upper triangle matrix, then what is going to be a lower triangle matrix? I hope you are following. If this is an upper triangle matrix, it will be just this, right? So let us draw a lower triangle matrix. So I am rubbing upper from here. Okay. So now we see what is lower triangle matrix and upper triangle matrix. So in this case, you can see that there is a matrix which is drawn 1, 6, 7. Column number 1 is 1, 6, 7, 0, 7, 9, and we have 0, 0, 8. Okay. Row wise, the first row is 1, 0, 0, 6, 7, 0, 7, 9, 8. Okay. So this is a matrix and this is the diagonal. So I have drawn the diagonal using this box. So this is the diagonal. 1, 7, 8 is the diagonal. The diagonal you know is like this, crisscross. So if you see the digits, the numbers which are above the diagonal, 0, 0, 0, all are zeros. Okay. So all are zeros. This is called a lower triangle matrix. Lower triangle matrix means a matrix where all the digits above the diagonal are 0. It is a lower triangle matrix, right? I am repeating what is upper triangle matrix? That means, please remember, up till now, we have discussed about the concept of matrix. It's an array of numbers. We have rows and columns. The general term of a matrix, of any term in the matrix, is Aij. We saw what is a scalar matrix. A scalar matrix is one where all the numbers in the diagonal are same. So a scalar matrix, we saw, is indicated by this K, 0, 0, 0, 0, 0, 0. K. All the numbers in the diagonal are same. Then we saw what is unit matrix. Unit matrix is where we have K equal to 1. You have 0. The idea is, in case of a unit matrix, is 1, 0, 0, 0, 1, 0, 0, 0, 1. So the diagonal is composed only of 1. Similarly, now we come to the lower triangle matrix and the upper triangle matrix. So first we are looking at the lower triangle matrix. This is the diagonal. All digits above the diagonal, all digits start karo. Okay. So we have seen here that if you see the matrix, we are having, I am writing the matrix 2, 7, 6, 0, 3, 4 and 0, 0, 7. So, right, we have, okay. Yes, 2, 7, 6, 0, 3, 4, 0, 0, 7. Seen here that, yes sir. Okay. So here again we draw the diagonal. Okay, the diagonal is 2, 3, 7. But please note that the digits below 2, 3, 7, we have 0, 0, 0. Okay, 0, 0, 0. This means this is a case of upper triangle matrix. So please note, this is a case of upper triangle matrix. Upper triangle matrix means all the digits below the leading diagonal are 0, 0, 0. Okay, so we have discussed about scalar matrix, unit matrix, upper triangle matrix and lower triangle matrix. Now we shall move into what is called a submatrix. Okay, page 2.38, we are continuing 2.38 of your study material. 2.38. Okay, so we are continuing with scalar. We now move on to submatrix. Okay, now in case of submatrix, let us draw a 3 by 3 matrix first. We are drawing a 3 by 3 matrix. Okay, let us draw 7, 6, 7. I am drawing up a matrix. 3, 2, 0 and 5, 5, 4 and 1. Okay, so the row number is 7, 6, 7, row number 1, 7, 6, 7. Row number 2 is 3, 2, 0 and the row number 3 is 5, 4, 1. Okay, we want to create a submatrix. So if I want to create a submatrix, what I do is, I will just say block this part. Okay, I am blocking this part. I am also blocking this part. Okay, so if you now see the matrix, you have, this is a 3 by 3 matrix. Originally 3 by 3. 3 rows and 3 columns. Okay, 3 by 3 matrix. But now we have blocked the middle 2 rows, and what we get is 7, here 7, a 5 and 1. So from the original matrix, we have got another matrix, and this matrix is called submatrix. Submatrix. Okay? Right. So these are important concepts which you need to have. Otherwise, we will not be able to understand and solve the problem. So matrix is an array of numbers divided into rows and columns. Normally, we use the term M and N. So a matrix can have M rows and N columns. In that case, it is called M into N. So A11, A12, like this it will go, A21, A31, A41. So like this it goes. We call it M into N. So it will have, M is the number of row and this N is the number of column. Okay, this we saw. Then we saw square matrix, rectangular matrix, and then of course scalar matrix, unit matrix, upper triangle matrix and lower triangle matrix. Now we go to additions of matrices. Okay, mathematical principle, there are 3. You have addition, you have subtraction, and you have multiplication. Okay, so first one, addition. So first we go to addition. We will take a simple example from the study material you can do with me. Okay. In fact, this question came in the exam in probably around one or 2 years back. This question came. This is matrix addition. Okay. So the matrix A is, I am writing matrix A, 1, 3, 1, 3, minus 2, 4, 2, 3, minus 1, 5 and 4. Okay, so this is the first matrix A, and you have the second matrix B. This is 5, 2, minus 1, 3, 1 and 2, 4, 3 and minus 2. Okay, once again please write with me. Matrix A, first row 1, 3 and minus 2. Second row 4, 2 and 3. Third row is minus 1, 5 and 4. And the second matrix is 5, 2, minus 1, 3, 1, 2, 4, 3, minus 2. We have to find A plus B. Okay. So in case we have to find this, I will draw it here. This plus this we will draw here. Okay. So first let us, row by row we will add, column by column we will add. Okay. So you will get the sum of two matrix or the addition of two matrix. Fine. So now you have the first one, 1 and 5. We are going row wise first. So we will go like this. Row 1, row 2 and row 3. Please note the 3 by 3 matrix. This one is a 3 by 3 matrix. This one is also 3 by 3 matrix. Right? So we are going row wise. The first one, 1 plus 5. So 1 plus 5, I am writing the direct number here. 1 plus 5 is 6. 1 plus 5, 6. Okay, 3 plus 2. So 3 plus 2. Please do with me. Use a pen, different colored pens. 3 plus 2. Very interesting and fun. Okay, so 3 plus 2 is 5. 3 plus 2 is 5. Minus 2, minus 1, we are adding. So minus 2 minus 1. Minus 2 plus minus 1 is minus 3. So I write minus 3. As simple as that. 4 Now we go, first column is done, first row is done. Row number 1 is done. Row number 2. Okay. 4 plus 3. So 4 is circled. 4 plus 3. 4 plus 3 is how much? 7. So 7. 2 plus 1. 3. 3 plus 2 is 5. So 5. Now we go to the third row. Row number 3. I hope you are following. Right? Row number 3. We have -1 and 4. So -1 plus 4. -1 plus 4 gives me +3. -1 plus 4 gives me +3. So I write 3. Okay. Then we have the next one. 5 plus 3. 5 plus 3 is 8. And we have 4 plus -2. Here we have -2. Here we have 4. So 4 plus -2 means 4 minus 2. That is 2. So it is done. As simple as this. Nothing to worry. So just add row-wise the numbers. You have the addition of two matrices. But be calm, quiet, pay attention, concentrate. Otherwise, one mistake means the matrix will be wrong. Okay. So this is as simple as that. This is the addition, right? Now let us go to another addition. Okay. Now we will take another addition. Okay. So I hope you have understood this. I am rubbing this and we will do another addition. Okay. Okay. Now I am writing G, a matrix G. G is not a square matrix. G is like this. Let's call it 1, 2, 3, 4 and 6, 7. Okay, G. So it is, G is what type of matrix? Dear students, anyone can guess? Okay, it is a 2 by 3. Row is 2 and column is 3. So 2 by 3. 2 by 3 matrix. And let us take another one, say F. Matrix F.
Hello,
So
sir.
this one is 1, 0. Yes, sir.
Hello, sir.
Hello, sir.
This is 3 rows and 2 columns, na?
Which one, sir?
This G
3 rows and 2 columns. Yes, 3 by 2. Yeah, 3 rows
3
and 2 columns. Yes, yes. 3 by 2. Yes. Okay. Now we go to the next one. So let us take column number, another one F. So we have 1, 0, 1, 1 and we are having 0, 1. Okay. So in this case, we are having, again, it's a 3 row, 1, 1, 1. So it's again a 3 row into 2 column. Column is 2, 3 rows. Now what we do is we add them. So F plus G. The same principle as we saw in the last example, number by number. So here what happens is we add up. So we get 1. I am using a red color now so that you know 1 and 1.
Sorry,
That gives me
sir?
2. Yes, sir.
The
Yes, sir.
order of the matrix should be same while adding the two matrices.
Yes,
Is it
absolutely.
right, sir?
Absolutely.
Okay.
Yes. I will mention that. Yes. Okay.
Yes.
So that's why I am taking identical matrix. I will tell them. Yes. So 1 plus 1 is 2. Right? And you also have, next one is 2 plus 0. Okay. So 2 plus 0 is 2. And you have 3 and 1 is 4. We are going to the second row. So 4 plus 1 is 5. And moving to the third row, 6 plus 0 is 6. And 7 plus 1 is 8. Right? So please note that these two, 3 by 2 into 3 by 2. But if it is 3 by 2, one of the matrix is 3 by 2 and another matrix is different. Say, unless they are the same, identical, you cannot add. So if it is say 3 by 3, it will pose difficulty. So it has to be identical. Only then you are able to add. So this is an example of addition. So number by number, we take each of them and we add. So this is how matrix addition is done. Now we will take another two matrices. This one was a rectangular matrix. I will take another rectangular matrix. This one is 3 by 2. Now we will reverse it. We will have 2 rows and 3 columns. Okay. So we will take another matrix and see how to add. Please practice with me so that it becomes easy for you. This chapter is very simple and not much to worry about. I am taking the next example. I am taking matrix A. This is 5, 2, 3 and let's have 1, 2 and 7. Okay. So we are having, please see that number of rows 1 and 2. So 2. And number of columns is 3. So 1, 2 and 3. So 2 by 3 matrix. Now we are taking another matrix B. Let us draw this matrix. This is say 6, 7, minus 2 and we have 3, 5 and say a bigger number 19. Okay. So in the case of matrix B, I hope you can see the two matrices. In the case of matrix B also, please see they are identical. Unless you have equal type of structure, 2 by 3. So this is also 2 rows and 3 columns. 2 rows and 3 columns. So it is also 2 by 3. Otherwise you cannot add. It has to be same. In the exam, of course, you will be getting these type of problems where the two matrices are identical in the sense that the structure is identical. 2 by 3, 3 by 3, it should be same. Otherwise, you cannot add. So in this case, if you add it, what happens? I am drawing it here. So 5 and 6. So let us draw it. Let us add it up. 5 and 6 is 11. So first digit is 11. We are going row wise. It is better to go row wise. So I am taking the first row and first row here. So 2 plus 7 is 9. So this is also done. And row number 1, the last digit is 3. Here also we have minus 2. So 3 minus 2 is 1. So I write 1 here. So the first row addition is over. So we have 11, 9 and 1. Now we go to the second row. You have 1 and 3. So it gives me 1 plus 3 is 4. So I write 4 here. 2 and 5. 2 plus 5 is 7. So I write 7 here. And 7 and 19. 7 and 19 gives me 26. So I write 26. It is done as simple as that. Okay. So I hope you can see the addition part. Now let us go into subtraction. Okay. Subtraction rule is also very simple, very similar to normal algebra, what you know. So we have done so many things today. We started with matrix. We learned about square matrix, rectangular matrix. We saw the general term of the matrix Aij. Then we saw what is a scalar matrix. We saw the diagonals of a matrix. We saw unit matrix. Then we understood upper triangle matrix, lower triangle matrix. Then we looked at additions. I took number of examples and solved it. See, as I said, ready-made solution. It is 2 minutes for me to use screen share, but it will be of no use. When I take other sessions on different other topics like risk management, economics, okay, then it works. But here it will not work. So here the idea is to break down. If you have a slide, it is not possible to break down. I can only highlight, but I cannot break down. I cannot use so many colors. Electronic pen is easy to use, but it is not going to serve your purpose. This is the way to learn mathematics, especially for those of you who are not having mathematics background. Ready-made PPT and screen sharing will not work, right? So now let's go to subtraction. So now we are subtracting. Okay. Let us take A. We are taking a particular matrix A. Okay. We have 5, 2 and 3. 5, 2 and 3. Row number 1, 5, 2 and 3. Row number 2 is 1, 2 and 7. So we have 5, 2 and 3, 1, 2 and 7. And we have the second row. We have the second row, 6, 7, minus 2. I am taking a negative number. I am taking 3 here, 5 here and 19 again. Okay, bigger number. So A and B, right? So we have to subtract. Same rules of algebra. So we are doing A minus B. In case of addition, we added each and individual number. Each number from the first row. So this is Aij, right? So in this way the J will change. If this is A11, this will be A12, A13. This is A21. So now number wise we add, but this time we will subtract. So let us see what will be the condition when we subtract. So we are having the first, we are taking row. Okay. Please also note this particular matrix A has how many rows? It has 2 rows. So it is a 2. Number of columns, it has got 3 columns. So it is a 2 by 3 matrix. Let us see the second matrix. Again you have 2 rows, first and second row, but you have 3 columns. So it is again a 2 by 3. So these two matrices are again identical in the sense that they have the same number of rows and columns. If they do not have similar number of rows and columns, you cannot add or subtract, right? So here let us do the subtraction. First one, we are taking the first row, the first digit 5. Here you have 6. 5 minus 6. We are subtracting B from A. So 5 minus 6 is how much? Minus 1. So I am writing minus 1. This is, I am creating a new matrix here. I am writing minus 1. Okay. So this part is over. So I am circling it with a red color. Okay. Next I am taking up 2 and 7. 2 minus 7. 2 minus 7 is minus 5. So 2 circled, 7 is circled, it becomes minus 5. The third one is the last digit in the first row is 3. And here we have minus 2. But we are subtracting. So it is 3 minus of minus 2. That is 3 plus 2. That is 5. Right? You know sign will change. Minus and minus makes plus. So 3 minus minus 2, this becomes 5. So the first row is over. Minus 1, minus 5, 5. Let's go to the next row now. You have 1 here, you have 3 here, right? So 1 minus 3 gives you minus 2. So I am writing minus 2. You have 2 here, you have 5 here. 2 minus 5. 2 minus 5 is minus 3. So I am circling this and I am writing minus 3. You have 7 here. Last digit, row number 2, last digit. This is also the last digit of column 3 because this is the third column. So 7 and 19. So 7 minus 19 gives you minus 12. 7 minus 19 is minus 12. So I'm writing minus 12. Okay. So this is subtraction. So now if you see, if I call it a new say matrix, if I give a new name, say it is C. C is equal to A minus B. So C is minus 1, minus 5, 5, minus 2, minus 3, minus 12. Okay. So we have seen addition and now we have seen subtraction. Now we proceed to scalar multiplication. And then slowly we will move into determinants and Cramer's rule. Okay. So now we go into scalar multiplication. Let me take an example from the study material. So page number 2.39. I am opening the study material, page number 2.39, exercise 2. Okay. So example 2, page 2.39. Example 2, page 2.39 of the study material. So I am drawing the matrix A. A is equal to say 2, 3, 4 and 5. 2, 3, 4 and 5. Right? So 2, 3, 4 and 5. Now we are doing scalar multiplication. So example number 2, page number 2.39. So this is scalar multiplication. So you are given this is a matrix 2, 3, 4, 5. You can see there are 2 rows and you have 2 columns. So this is a 2 by 2 matrix. 2 by 2 matrix. Okay. And you have been given scalar means you have to increase the scale, right? Say if I say that, simple, I'll take a very simple example. Say a room has 5 feet by 3 feet, a very small room, a dingy small room, no breathing space, 5 by 3. I ask you to make it bigger 3 times. So k equal to 3. So what will happen? You will multiply 3 into 5 becomes bigger, 15 feet, and this also 3 into 3, 9 feet. So now the room is, bigger and airy and spacious, 15 by 9. Okay? So from 5 into 3, it has become 15 by 9, right? This is scalar multiplication. Same thing we will do here. Okay? I'm using very simple examples to make you understand so that mathematics is fun and mathematics is scoring and mathematics is interesting also. Right? So 2 by 2. Now we take k equal to 3. Simple. Just multiply all these numbers by 3. So what will happen? Okay. So the scalar multiplication k into a. K is 3. K into a is equal to 3 into 2. Row number 1, first digit 2. 3 into 2 is 6. 3 into 3, second digit is 9. 3 into 4 is 12. And 3 into 5 is 15. So you have the new matrix which is a product of k and a, 6, 9, 12, 15. Right? So this is as simple as this, scalar multiplication. Okay. Now I will take another example of scalar multiplication. Right? So it will, basically improve your understanding. This is from the study material. Now something which I have, not from the study material, from exam question which came in CA exam earlier. Okay. The A is, the matrix is like this. 2.1, 3 and 2. 5, 1, 6. Matrix is given. You are told you have to find k equal to 2. Right? So the matrix is given. Please note that the matrix is having 1 and 2. 2 rows and 3 columns. So it is a 2 into 3 matrix. 2 rows, 2 rows and 3 columns. Okay? Now we have to find Ka. That is, we have to find 2a. Okay. So what do? We straight away multiply each and every number of this matrix by 2. So 2 into 2.1. So please, 2 into 2.1 is how much? 4.2. So I write 4.2. Okay. Next is, so this is 4.2. 2 into 3 is 6. 2 into 2 is 4. 2 into, so first row is over. So I'm indicating with a red color. So we have completed the first row. Done. Now we start with the second row. 2 into 5. Okay, how much? 2 into 5 is 10. So 10. 2 into 1 is 2. And 2 into 6 is how much? 12. Okay, it's done. As simple as this. It's done. So this is 2a. Right? Now we move on to, so it is 4.2, 6 and 4, 10, 2 and 12. This came in the CA exams, in the foundation exam. Okay. Now let us take multiplication, right? Last part. And then we'll move into the other areas, Cramer's rule. Okay. We will take a multiplication and then the Cramer's rule. Okay. So let us take the multiplication here. Say A is equal to 5, 2 and 3, 1, 2 and 7. So you can see this is a number of rows are 2 by 3 matrix. Okay, it's a 2 by 3 matrix. Okay, 2 by 3 matrix. Right. And the other one I'm taking is B, and B equals 3 minus 2, 5 minus 8, 9 and minus 10. Okay, now we will have some fun, right? We will see how to multiply and say this is A and this is B. We have to find the product A into B. Okay, we have to find the product A into B. Please note that we have done the scalar multiplication. In case of scalar multiplication, of course, we found that we are multiplying with a fixed number, but here it is different. So what we do here is, in order to multiply, now we will go according to row versus column. Okay? So row versus column. So we have 5, 2, 3. The first row is 5, 2 and 3, and the first column, if you see, the first column is 3, 5 and 9. So what we will do is we will multiply each of them row wise and column wise. So first one, 5 into 3, we have to write now, okay? The first product, 5 into 3, 5 into 3 plus 2 into 5. So row into column. So 2 into 5, that is 10. Okay? Plus 3 into 9, that is 27. So you have the first, we are drawing the matrix here. So we will have, let us see the matrix which will create 5 into 3 plus 2 into 5 plus 3 into 9. So you can see in this multiplication, the rule is that first matrix, the number of column which you have must be equal to the number of rows of the other matrix. Okay. Similarly, the number of columns in the first matrix, 3 columns. In B, we have 3 rows. In A, you have 2 rows. And in B, you have 2 columns. So, A number of columns should be equal to, here we have 3, it should be equal to the number of rows in the other matrix. Only then the multiplication will be possible. So, 5 into 3 plus 2 into 5 plus 3 into 9. Okay, so that gives me 15 plus 10 plus 27. So, it is 52. So, I write 52 here, first digit. Next one, please see. Second one will be this row and this second column. So we have 5 into minus 2, that is minus 10, plus 2 into minus 8, that is minus 16, plus 3 into minus 10, that is minus 30. So minus 10, minus 16, minus 30, so that is minus 56. Okay, so we have got 2 numbers. The third one, row number 1 versus column number 1. So we have done row number 1 versus column number 1. Then we did row number 1 versus column number 2. Now we are going to do row number 2 versus column number 1, and then row number 2 versus column number 2. Okay. So now 1 into 3, I will write here. 1 into 3 is 3. 1 into 3 plus 2 into 5, 10 plus 1 into 3 plus 2 into 5 plus 7 into 9 plus 63. So you have 63 plus 10, 73 plus 3, 76. Okay, and let's see the last one. So this will be column number 2 and row number 2 and column number 2. So 1 into minus 2, that is minus 2, plus 2 into minus 8, that is minus 16, plus 7 into minus 70, that is minus 70. Okay, so this becomes minus 70, minus 16, minus 2, that is minus 88. This is a little difficult, not so easy as scalar multiplication, little difficult, but I hope you understood. So row wise and column wise we multiply. Row number 1 first number into column number 1 first number, row number 2 into column 2. So the second number, row 1 second number into column 1 second number, plus row 1 third number into column 1 third number. Okay, then we have row 1 first number into column 2 first number plus row 1 second number into column 2 second number plus row 1 third number into column 2 third number. You get this, and then similarly you move to the second row and complete that with first column and second column. So we have 52 minus 56, 76 and minus 88, right? So this is what is multiplication. And now we go to the last part. A question is, a very important question is that in case of algebra, you know a very easy relation that, A plus, let me put it in this way, that say A plus B plus C is equal to A plus B plus C. Okay, simple. We also know A into B, a product of two numbers is equal to B into A. So whether I do 3 into 5 is equal to 5 into 3. Okay, 9 into 8 is also equal to 8 into 9. In general, A into B is equal to B into A. But in matrix, is it so easy? In matrix, will it hold good? If you multiply two matrices A into B, will it be the same as B into A? Okay, I will not jump to any conclusion. Let us do it first and see. Okay, so the question is, I hope you are following. Okay, we are taking extra time today and we are working really hard, you can see, right? Not a single second of rest, continuous analysis and solving of problems. Same on your part. That's how together we make it happen. Okay, so let's take a very easy example to see whether AB is equal to BA or not. Right. So let me take a simple example A. Our question is whether AB is equal to BA, question mark. Okay, whether AB is equal to BA. Now the question is, I'm taking A, 6, 3 and 2, 5. 6, 3 and 2, 5. This is A, and we have B. We have B, another one. This is minus 3, 2, minus 3, 2, 1 and 5. Minus 3, 2, 1 and 5. So, just asking to wait. Okay, so we have 6, 3, 2, 5 and you have minus 3, 2, 1 and 5. Right? So these are two, we are having two matrices. Please note, these are 2 by 2. So you have 2 rows and 2 columns, 2 into 2. This is also 2 into 2. Okay. Now, let us find out the product. Okay. Possibly this will be the last thing we'll do today. And we will take up because, syllabus is vast and too much. If you have one day, you go mad and you won't remember anything. We will stop here and we will take up Cramer's rule because determinants and Cramer's rule is, right, we'll take it up on the next day most probably. Right. So you have A and B and you can see that the product we have to find out. So we are first taking the product of A and B. So let us do it together. Right. So A is 6, 3, 2, 5 and B is minus 3, 2, 1 and 5. 5 terms. Okay. 6. So the rule is go row versus column. Row versus column. So 6 into minus 3. So I'm writing here 6 into minus 3. 6 into minus 3 plus 3 into 1. Plus 3 into 1. Okay. Right. Second one. So now we go for the second one. 6 into 2. 6 into 2. So column, row 1, column 2. 6 into 2. 6 into 2. Plus 3 into 5. So 3 into 5. This is complicated. Please do with me. This I am telling you is complicated, difficult, but not impossible. Right? I will never undermine it and say it is very easy. No, it is not easy. Scalar multiplication is easy, but real multiplication of two matrices is not a joke. So please pay attention and please see the video later on in YouTube. We are doing through online mode. There is bound to be IT disruption. Even if you do it from a professional studio, there will be disruptions. But please bear with that because This is an online platform and there will be IT problems sometimes, but try to focus on what is being discussed and try to do it slowly, practice with me, and then go through the chapter once again to have more command. Right. So you have 6, 3, and what we have done, the first one we have multiplied 6 into minus 3 plus 3 into 1. So we are going row wise here, column wise here. The second one we have done 6 into 2, right, plus 3 into 5. We have done it. Now we go to the second row and we try with the first column. So 2 into minus 3, 2 into minus 3, 2 into minus 3 plus 5 into 1, 5 into 1. And now we have the last one. So we will take row 2 and column 2 here. So 2 into 2, that is 2 into 2 plus 5 into 5, 5 into 5, right? So let us simplify. 6 into minus 3 is 6 plus minus, we have 6 into, we'll just check, 6 into minus 3 plus 3 into 1. So this gives me minus 15 because minus 18 plus 3. This gives me minus 15. The second one is 6 into 2, that is 12, plus 3 into 5, that is 15. So 12 and 15 gives you 27. So I write 27 here. The third one, 2 into minus 3, that is minus 6, plus 5 into 1, that is 5. Minus 6 plus 5 gives you minus 1. So I write minus 1. And the last one is you have 2 into 2, that is 4, plus 5 into 5, that is 25. So you have 29 here, right? Please note it down because I'll rub it because we will now go for BA. I am also noting it down in a separate sheet of paper. Okay, so I'm noting it down that AB, A and B. So AB matrix comes to minus 15, 27, minus 1 and 29. I have written it. Please do write it because we are proving something. We are not accepting any rule. We are not accepting, no, we are not blindly memorizing any law. If I just show you a PPT, you will blindly memorize. But if you practice it like this, you will never forget, even in the exam condition. This is the way to learn maths. And this is the way chartered accountants work. No theory, only practical. Okay, now let us see. So we have noted this. I am rubbing it out. I am rubbing this part. Rub it out. Okay. Now we will do B into A. Right. So I'll rub this and write BA. Altogether rubbed out. B now. If you see the matrix B, once again let me go. The B matrix was minus 3, 2, 1 and 5. Minus 3, 2, 1 and 5. And A is 6, 3, 2 and 5. Okay. Now we are doing BA. BA. So the rule will be same, but the sequence will change. The first one, I am using red and blue together. Minus 3 into 6. Okay. So row 1, column 1. Minus 3 into 6. Plus 2 into 2. So plus 2 into 2. We have done the first one. Now we go to the second one. Minus, now this will be minus 3 into 3. So minus 3 into 3 plus 2 into 5. So plus 2 into 5. Okay. Now we go to row number 2 here. Row number 2 is 1 into 6. So 1 into 6. 1 into 6 plus 5 into 2. 5 into 2. Okay. This side we have 1 into 3. So now row 2, column 2. 1 into 3. 1 into 3 plus 5 into 5. 5 into 5. Let us simplify. Equal to. I hope you can see so much of hard work goes into discussions and you have to work with me together. Even though we are not connected physically, but we are connected on online platform and you have to work with me together. The more you do paperwork, whether it's accounts, only learning about accounts, PPT after PPT, screen sharing, oh, so much I am learning. Nothing goes here unless you practice. Only PPT, screen sharing and little bit of this will not serve the purpose. You have to use a hands-on approach the way I'm doing, the way I'm requesting you to do. That's why even when I'm talking about the responses, I am also mentioning your name, who has sent what query. Right, this is the way we have to work together so that you be successful. CA is not an academic course, it's a professional course. It is meant for the best to survive. It is a survival of the fittest. So we have to go in depth. Understand, speed up, use confidence, be successful. Right, that's the way. So let's do here. Minus 3 into 6, minus 18 plus 4. So minus 18 plus 4 gives you minus 14. Fine. This side we have minus 3 into 3 is minus 9 plus 10. Minus 9 plus 10 gives you 1. So 1. Second we have 1 into 6, that is 6. Plus 5 into 2 is 10. 6 plus 10 is how much? 16. Right? And the last one, 1 into 3, that is 3. Plus 5 into 5 is 25. So 3 plus 25 gives you 28. So we have got BA. Now let me see. Right? Let me go to my notebook and see what I wrote. You have it with you? I hope so. AB was minus 15, 27, minus 1, 29. And VA is minus 14, 1, 16, 28. Are they equal? Do you find the numbers are same? So this is BA, and let me just rub up the upper part. So this is how we don't memorize, don't mug up, no shortcuts. If you really want to go into accounts, no shortcut in accounts. You have to remember the format of financial statements. Schedule 3, you cannot forget accounting standards. No shortcut in life. Shortcut is always the wrong cut. Exam, yes. Reasonable speed, confidence and time management. So AB we got was minus 15, 27, minus 1, 29. And BA we got is minus 14, 1, 16 and 28. Are they equal? Can we say AB equal to BA? Question mark? No. So please remember, very important rule of matrix, AB will not be equal to BA in general conditions. Right? So I think it's almost 4:20 and there are some more questions to be done. I will just take another 2-3 minutes and then wind up. Okay, we are having a non-stop session. Few numericals are there. There's a large chapter and the first part is easy, but the next part, determinants and Kramer's rule, initially is not so easy to digest. It will take some time to understand, but let us go into determinants. I'll just take determinants and complete today. Okay. So I hope you have seen, we have done a lot of things together today. Addition of matrices, we have seen what is a matrix. We have seen what is a scalar matrix. We have seen what is something is called, there's a transpose matrix also. Let me just quickly show you the transpose matrix. Okay, so matrix, say it is 1, 7, 6, 2, 4, 8, 0, 1, 9. Okay, this is a matrix, 3 rows, 3 columns, 3 by 3. So 3 by 3. Transpose matrix. What will I do? Transpose means from this side to this side, up to down, down to up. So 1 will remain here, but this 7 will come down. 7 and 2 will interchange. So 7 will come here, 2 will go here. Okay? 6. Okay, so 7 and 2 interchange. 6 will come to here and 0 will go here. So 6 and 0. So 6 comes here, 0 goes here. 4. Diagonal, the center part remains as it is. But here 8. Beside 4 we have 8. Below 4 we have 1. This 1 and 8 will interchange. Okay? So we will have 8 here, 1 here. 9 will remain as it is. So please note, this is the transpose matrix. It comes very frequently in your exam. Matrix is given, find out the transpose matrix and add so and so, or subtract so and so, or multiply so and so. So we have seen what is matrix, we have seen what is a scalar matrix, we have seen 2 by 2, 3 by 3, we have discussed about additions of matrices, subtraction of matrices, scalar multiplication, upper triangle matrix, lower triangle matrix. Then we saw what is multiplication of two matrices, and we proved a very, very important law in general. Matrix A into matrix B is not equal to matrix B into matrix A. Right? I hope you can see the difference the way we are discussing. If I had done a screen sharing on a PPT, right? Some of the students are writing, why please share PPT. No, this is not the way, at least not my way. Because if I share PPT, it can be done for other subjects, not for maths. It's a dynamic subject. You can see so much of writing, so much of underlining. It is not possible on PPT. We are senior chartered accountants and very comfortable on all types of IT platforms, let me tell you. But we have to understand the target audience. I am discussing these matters with people who are learning and appearing for CA Foundation Mathematics. And this is a new paper for many of them. All the chapters are not easy. Some of them, yes, are tough. So, according to the audience, according to the need, the technique will change, right? So, we have seen so much of matrices and we proved that AB is not equal to BA. Finally, we saw what is transpose matrix. I will end today with the basic idea of determinants, and next day we will quietly move into Cramer's rule, which will be giving you an idea of how to solve. What is Cramer's rule? Cramer's rule is a way in which we can solve linear equations involving two unknowns, x and y, and three unknowns, x, y, and z, using determinants, using matrix. So, let me show you how to find out determinants. What is a determinant? Okay, determinant. Okay, you have to be determined, and this is a determinant. I am taking a simple matrix, A, B, C, D. Okay, determinant means the value of this matrix will be like this. A into D minus B into C. First diagonal AD, okay, minus BC. Okay, this is for a 2 by 2 matrix, right? But for a 3 by 3 matrix, little difficult, but not impossible. Okay, let's see the 3 by 3 matrix rule, and we will take a numerical which came in the exam, then we will complete. Okay, for a 3 by 3 matrix, okay, so I am drawing the matrix A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, row number 1, A1, A2, A3, row number 2, B1, B2, B3, and row number 3, C1, C2, C3. Okay, please draw it, please write it, hands on way. Okay, now the determinant of this, sometimes shown by delta or by the short form det. The determinant will be like this. Be very careful. First we take A1. A1. Leaving A1, we focus on this one now. Draw. We focus on this 4. Okay. And we use the diagonal principle. So B2C3 minus B3C2. First this and this. Okay. You say no. No means no. No. Cross. Okay, this slashing this way and this way. First left to right slash and then right to left. This. So B2C3 minus B3C2. B3C2. First part is over. Now remember the sign. It's a negative sign. Minus A2. So minus, now we are taking A2. If you take A2, now you have to consider B1, C1, B3 and C3. So it is A2 multiplied by B1 C3 minus B3 C1 minus B3 C1 plus the last part plus, now we will take A3. So we will take A3. Okay. A3 if you take, that means this full column is gone. So you have B1 B2 C1 C2. So you take B1 C2 minus B2 C1. Minus B2 C1. Looks bit difficult. Yes, but then what is life unless you have challenges, right? Everything cannot be a cakewalk, right? Every professional course requires some hard work. Same here. But it is, you are learning for the first time. Next day, You remember first day when we did quadratic equations? Oh, so tough. What is sir saying? Second day, I think what he's saying makes sense. Third day, yes, I understand. This is the way we move. Same thing here, right? And I keep on revising every 15 minutes. I give you once again what we have learned, so you remember. And if you do it with pen and paper, it becomes easy for you. This looks very difficult because I have used mathematical A1, A2. Now let us do it with a number and we will end. Okay? Determinants, once you understand, Kramer's rule will be easy. I am taking a simple matrix and we will find the determinant. Okay? Matrix is this. Take some easy numbers. 2, minus 1, 6, minus 3, 4, minus 5. And I'll take 8, minus 7 and minus 9. Okay, minus 9. I'm taking all possible negative and positive signs so that it becomes a little exacting. Okay, just completing in 2 minutes. 7 into minus 5. Now 7 into minus 5 is how much? Minus 35. So I have to write minus 35. First part is done. Now in case of A1, A2, A3, A1 positive, A2 in front of A2 we have minus sign. So it will be minus. Minus. A2 is how much? Minus 1. So this is minus 1. And what we will do now, so this part is gone. So we will focus on what? We will focus on this part. So minus 3 into 9, minus 27, minus 8 into minus 5. That is minus of minus 40. Plus, last is 6. This is A3. So now we focus on this part. Minus 3 into minus 7, that is 21. Minus 4 into 8, 32. Let us see what we get. Minus 36, minus of minus 35. That means minus 36 plus 35. That is minus 1. Minus 1 into minus 2 gives you minus 2. Now you have minus into minus 1 gives you 1. Here you have minus 27, minus of minus 40 becomes plus 40. So it becomes minus 27 plus 40. That is 13. 13 into 1 is 13. Plus you have 21 minus 32. 21 minus 32 is how much? Minus 11. Minus 11 into 6. So it becomes minus 66. Okay. So in this way we are, if now we simplify this, so minus 66 minus 2 is minus 68 plus 13. So we take A1, B2, C3 minus, so this is, you know, this is B1, B2, C3, right? And B2, C3 minus B3, C2. Then we take minus of A2, right? We have these two. And then we take A3, we have these two. That is B1, B2 and C1, C2. Right? So I think we had a long discussion. I am wrapping up what we did. We are only left with Kramer's rule, which we'll do. We have done number of responses I gave to many of the queries which came on linear, quadratic and cubic equations. We started with matrix. We discussed about matrix, rows, column operations, 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix, square matrix. Then we had rectangular matrix. We talked about the scalar matrix, unit matrix. Then we discussed about something called upper triangle matrix, lower triangle matrix. Then we moved into additions of matrix, subtraction of matrix. Then we discussed about scalar multiplication. Then we had multiplication of matrix, where we learned that A and B, if you multiply, the number of rows in matrix A must be equal to the number of columns in matrix B, otherwise you cannot multiply. And then together we found out that AB is not equal to BA, right? So with that, we complete this session. At the end, we did determinants, and I talked about 2 by 2 determinant, 2 by 2 matrix, how to find the determinant, and in case of 3 by 3. So it's almost 4:30 now. I wish you very best in whatever we are discussing and learning. Please grasp and try to study yourself and go through the study materials. So with that, I'm ending this session today. Next day, we'll start with the Kramer's rule and move on to inequalities, right? Stay tuned and stay safe. Thanks a lot for joining. And please do see the YouTube video once it's uploaded. Any queries, get back on the next day. We'll sort it out. Thank you and have a great time ahead.